Science Sort of is recorded using Zencastr. Use the promo code SCIENCE to get 20% off your order at zencastr.com. That's ZNCASTR.com. I am recording now, Joe.
Good to know.
Oopsie doopsie. To do John Lovett's impression of Seth Gorka.
Indeed.
I was tired. That day. I'm tired today. Apparently, wow, I've somehow put myself in the same mood. Completely unintentionally for these two segments recorded definitely not sequentially. Go me go. I'm all about that authenticity, Joe.
You're getting yourself in the brain space so that the interviews flow smoothly into the PaleoPOW.
Some kind of space.
From ScienceSortOf.com, you're listening to Science Sort of.
Welcome to Science Sort of. You are listening to episode 275. I'm your host, Ryan Haupt, and joining me to talk about things that are science, things that are sort of science, and things that wish they were science, centered around the theme of publishing rocks, are my guests, Chris Jackson, who is a professor at Imperial College London of Basin Analysis in the Department of Earth Science and Engineering. Hello, Chris.
Hello, that's me.
And also joining us is Tom Narock. Am I saying that right?
Yes, that's right.
Who is at Notre Dame of Maryland University, who's an assistant professor there, also doing geoscience work in data science and the semantic web, which is kind of an interesting crossover. So thanks for joining us, Tom.
Thanks for having me.
Let's start with talking with Chris a little bit about the research you do. So you're a seismic guy, and we actually, even though we are both theoretically in our own way geologists, we had a little dino chat on Twitter. I don't know if you remember that, Chris.
Oh dear, what did I say?
I think it was something to do. It was something to do with you have children and your children weren't sure about birds being dinosaurs.
Oh yes, no, they believe it now.
Yeah.
They believe.
Okay, good. So we got that.
Yeah, they believe most of what I say. So this has been handy in terms of telling them something which is true, as opposed to all the other stuff I tell them.
You have to tell me that trick because my kids don't believe anything I tell them.
No, that's true. They normally look at their mother and then try and get sort of like some qualification from her. But yes, yes, I am a geologist by training.
Okay, and so you look at a lot of what you kind of told me was you look at how the crust is deformed and then how that deformation affects landscapes and seascapes.
Yeah, so I'm interested in the plate tectonics and structural geology. So when we get mountains built or when we get rift valleys forming, and then how what those landscapes look like, but not really present day because that's more of what we'd call geomorphology. Mm-hmm. I'm kind of as interested or more interested in what they look like in the past, so how we can try and read the rock record to try and deduce how tectonics, sea level and climate are interacting through time. So up to, no rock is too old. We look at things which are 400 million years old using seismic reflection data typically, but also using field data and going out and collecting.
Yeah, so I don't think we've ever actually had someone on the show who uses seismic data in that way. I think most people, when they hear seismic, they think, earthquakes, and there have been some really terrible earthquakes in the news lately, and so people are probably just focused on the human tragedy side of that part of living on a planet with active plate tectonics. So can you tell us a little bit about how you're using that data in a positive way, or at least in a way that helps us better understand Earth?
Yeah, so it's interesting because a lot of that, so I think there's a bit of a misconception about seismic data in a way because it's considered a geophysical tool. So it's like the preserve of geophysicists, but it's a very useful tool for geologists. So I have no formal geophysical training, but the seismic data I kind of stumbled into during my PhD. So this amazing data kind of allows us to image the subsurface of the Earth. So I often say to people, it's like producing an X-ray of the Earth. So we can use our geological minds to interrogate that geophysical data. And again, another thing that people sometimes don't understand if they've been using seismic reflection data academically is a lot of that data comes from the oil industry. So from the hydrocarbon exploration industry.
Right, because they can use that seismic data to find pockets of liquid
oil and gas. Yeah, exactly. So those data cost a lot of money to acquire because you send out a boat with a bunch of people on, and these experiments take weeks, maybe even a few months to collect. So getting access to those data as an academic and those data cost millions of pounds, the shelf price.
Mm-hmm.
So we're very fortunate to get it to ask kind of really random questions about how magma moves through the Earth's crust in the Eocene 40 million years ago. But, there's lots of different things you can do with those data. And so, I kind of stumbled into that during my PhD, but I've been playing with it ever since.
Yeah, it's funny. The department I come from in Wyoming, obviously, it's Wyoming, so it produces a lot of people who do the geophysics and mineral, oil and gas exploration that you're talking about. And a lot of that data, if I understand, doesn't ever really get published in the scientific literature.
No, I mean, most of it, I don't even know what the percentage would be, but you probably could say 99% of seismic reflection data is acquired for applied means, and a bit of it gets into the, some of the industrial workers might publish, but it's not that common. And some of that data might make its way into an institution, academics' hands, and then, they publish some. But there's large swathes of the Earth's crust, onshore and offshore, which are imaged using those data. And there wouldn't be enough hours in the day or years in time to actually look at it all. For academic reasons.
Right. Well, Tom, don't want to leave you out. Can you tell us a little bit about your research and how you're more of a geoscience or a geophysics guy, I guess?
Yeah, I think I'm kind of the oddball here. Which one of these guests is not like the other guys? I kind of work at the intersection of computer science and earth sciences. So I kind of, as Chris was mentioning, I got started out in physics, and then along the way, kind of in graduate school, got really intrigued by the computing side of things. So I switched over to computer science, for my PhD. But I still really enjoy physics and geosciences. And so I work a lot with bringing semantics and logic to earth sciences and earth science data sets, with the idea being that we can transition computers from simply being tools that we use for research to being more intelligent collaborators and colleagues. And so I try to build more intelligent information systems, more intelligent search and retrieval systems that geoscientists can leverage. And again, with the intention of being that the computer is more of an intelligent colleague where it can understand the semantics and some of the domain concepts.
Yeah, that was interesting when you sent me some links for stuff to read up, as I was not expecting to get so much stuff about big data and the web, which is cool. So can you tell us what exactly does semantics mean? I think we often hear that tossed out as an insult of you're
right.
semantics.
So in this context, it's referring to methodologies and techniques for putting concepts and relationships into a form that a computer can understand. As in the geosciences, we have our own vocabulary and terminologies, and we say things with the understanding that our colleagues know what it means or what might be inferred from that. And there are techniques from computer science and mathematics that we can now put those relationships into a form that a computer can understand. And so we can ask questions of the computer, and it can deduce what additional information it might need to answer that question. It can reason about what data sets it might want to look at, what connections already exist. So it allows us to pose questions to a computer at a much higher level, and then the computer can do the legwork of deducing, what kind of resources and data sets am I going to need to answer this question?
And so can you give us an example of some of the, maybe a specific project that is facilitated by this kind of way of connecting computers to researchers?
So we just finished a project called GeoLink, where we were attempting to connect some oceanographic data sets to publications that resulted from them, to the people that were associated with them. In this particular context, there was a number of research cruises that went out to sea and made independent observations. But, over time, the different cruises went to similar places within the ocean. They had similar type of instruments. And so a researcher could come along and pose a particular, let's say, a phenomena that they're interested in. And the computer could say, okay, in order to answer that question, I can reason about what kind of measurements must be taken. And okay, now that I know what kind of measurements are taken because of the logic and the semantics that I have access to, I can see, which research vessels had instruments that could have potentially taken those kind of measurements. And so from there, I can recommend certain data sets to you. And then from there, the computer can infer, well, those data sets were maintained by these principal investigators. And I see from the publication records that these are the publications that have resulted from that principal investigator, or these are publications that have cited those data sets. And so we just can interact with the computer as if it were a colleague, and it can do the deduction and reasoning for us. And we found, and you mentioned big data, we've kind of entered this era where we have so much data available to us that, and Chris was just touching on this with the oil and gas examples, that it's not humanly possible for an individual researcher to really sit down and go through everything that we might even have access to. So if we can make our computer systems a little bit more intelligent and they can do some of this work for us, then maybe we have a chance of exploring all of those data sets and really integrating it and making new discoveries.
It sounds like you would instantly be most researchers' best friend, like if they meet you at a conference.
I'm not sure. I mean, as much as I like Tom, it sounds like the robots are going to take over the world. When you hear these people talking, I mean, it is clearly complementary to what we're trying to do, but I always find it incredibly amazing how much automation and how much intelligence we could gain from, developing these sorts of codes. So I always kind of, it excites me and scares me in equal measure.
And me as well, and I'm right in the middle of it.
Yeah.
But yeah, it's a great point, and I think we need to head down the road of the researcher and the computer working together. I don't intend to put anyone out of business. It's a slippery slope when the computer starts to make automated decisions for us, and so we really need to think about how humans and computers will interact together.
So do you think about that a lot, or are you more focused on just the research side of thing, and the speculative future is a little bit just for fun?
No, I really do think about that a lot, and I'm particularly interested in, as these capabilities get more and more sophisticated, how the general geoscientists can interact with them. It's quite a steep learning curve to learn some of these complicated query languages and some of these advanced technologies, and geoscientists already have enough to deal with. They don't need to, and they shouldn't have to spend extra time, figuring out all these new technologies. So, yeah, that kind of interface between our end users and making it a technology that falls into the background and becomes really seamless, that's a really intriguing area of research for me.
I mean, how much risk are we really at? Like, Chris, have you seen that video of the Swedish woman who makes terrible robots?
It flashed through on my stream, I think, on Twitter, but I didn't see it. I mean, I can well imagine.
It's worth your time. She's trying to democratize robotization by building robots that are really bad at their assigned task, but are technically functional, I suppose. So, I mean,
that sounds like me.
Right. I feel like every time we think about AI, definitely scares me more than robots. I don't know about you guys. I feel like,
a
robot we can blow up, but how do you blow up a program?
Yeah, Tom.
Sure, we're gonna have to put that in from the start.
I think the way this is going to work is he's going to spend his time coding all these things that are going to take over the world, and then hold us to ransom and go, oh, by the way, I'm the guy who can fix this for you. And then suddenly we're in his palm of his hand.
There you go.
You've discovered my secret plan.
You'll be the one scientist who's actually figured out how to be profitable.
Exactly. Yes, exactly.
Well, I not only want the AI that will discover the data sets for me, I want the AI that'll write the paper and submit it for me as well.
That'd be nice, yeah.
I mean, the file drawer effect could be eliminated overnight if somebody could just figure out how to get the...
Oh, God, no. Yeah, that would take a long time.
AI to automate the paper writing. Well, that's fascinating. And so do you two... We're going to talk about an initiative the two of you are working on together in our next segment, but how did you two... Are you connected through research, or are you just connected through this other project?
Just through EarthArXiv, really.
Okay,
isn't it, Tom? I think I'd never been into semantics and things before I met Tom.
Yeah, that's true. We kind of just met through this EarthArXiv initiative. And in fact, it's all been entirely through Skype and email. We haven't had a chance to meet in person yet.
Yeah, there are people I've done this podcast with that I still haven't met in person. Like, not just guests, but like people who've been co-hosts. So it's an interesting time to be alive. How do we know that each other aren't just AIs?
Yeah.
Maybe this is the Turing test right now.
No, exactly. I wouldn't be I wouldn't have a drawer full of papers if I was AI.
But that's what makes you pass as human, is being unproductive.
Nobody's ever accused me of that.
So, Chris, I want to hear a little bit more about what you do, because I want you to feel like we glossed over that. You kind of talked big picture, and it sounds like your work is very big picture just in terms of its scope. But can you tell us maybe about like a recent project or something that you've been working on specifically that you're excited about?
Yeah, so one bit of research we've been doing over the last, say, 4 or 5 years, but it was very new to me, was trying to understand basically how volcanoes or volcanic systems work. So how magma moves beneath volcanoes and may enter into the volcanic edifice and then be erupted. And, most classically, you would consider that to be a kind of near-surface phenomena, right? So you would go up to a volcano and stick a piece of equipment in it or near it, or put some seismometers down and try and record earthquakes within it. So you'd be monitoring active volcanoes, whereas we've been using this seismic reflection data to look at ancient volcanoes. So the idea being, if you can look at if you can use these sorts of data to image an ancient volcano, which is several tens of million years old, you can actually also see into the ground underneath it. So with a modern system, you can end up with all these non-unique, with a modern kind of modern surveying of an active system, you're left to guess at what all those signals mean. So you might have earthquakes, or you might have the ground deforming, and then you have to try and guess what the magma is doing and where the eruption potential might be within that volcanic system. Whereas we look at crystallized systems, or we call them fossilized volcanoes, because all of the magma has solidified to igneous rock.
As a paleontologist, I might challenge you on that term, but I might be semantic.
Yes, I mentioned it today, but we say it's frozen in time, and from that we kind of get a sense of where all the magmas come from over much longer length scales. So with those types of data, we can image down to several tens of kilometers in the Earth's crust. We can image things over several hundreds of kilometers, spatially. So that's been really exciting, trying to use those type of data. And for me, it was all brand new. I'm not a volcanic specialist, or I was never an igneous geologist, but I had these tools, this seismic reflection data, and then you can realize you can throw it at lots of really exotic and things that are in societal sense quite important for understanding how volcanoes behave. And we're trying to do that by looking at ancient systems.
Interesting. We don't really have a good method for predicting volcanic eruption. And I would say we have an even worse method for predicting future earthquakes. And so I imagine, you can correct me if I'm wrong, that the more we can understand the deep time perspective of how these things persist and repeat over Earth history, maybe the better we can do at understanding them in the modern system.
Yeah, no, I think you're absolutely spot on there. It's very hard, and it's very, volcanoes and hazards are very emotive subjects. They're very scary.
Well, those Italian scientists were put in jail.
Yeah, they were in jail for several years, weren't they? And then they were released, and then so when you open your mouth about things, you have to be, you have to have some sort of qualification. You also need to be very cautious of the way that will be interpreted by not just the media, but also by the people you're talking to. So be that a casual encounter with somebody in a bar, all the way through to a colleague in the corridor. If people react differently to that sort of message. So you have to be very, very careful. But, kind of fortunately for me, this work on the volcanic systems has been a kind of emerging kind of interest for me. So I've not quite been, got to the point where I'm talking about like prediction in a really direct way. But some of my friends who do, I know from them that it's a bit of an uphill battle against some of the negative messages that can arise from people saying the volcano will erupt tomorrow afternoon, and people start running and screaming and going around. You have to be very cautious. These
changes are really slow, and we still need to emphasize the severity of the coming problems, but screaming about it isn't working.
Well, this is a general basin analysis type question, right? So the Earth looks very slow, and even to me as a geologist who studied it for a long time, to the layperson, say the general public at large, there's nothing cracking, or there's no lava pouring out, or there's no earthquakes, so it all looks docile, the Earth. But then when those catastrophic moments come, they are just that, they are catastrophic, and it's kind of slow, quick, slow. It's hard to convince somebody there's a threat when there's not clearly a threat. There's nothing racing out the top of the volcano, so I'm not in danger. And likewise, the Earth isn't shaking now. so I'm probably okay. And you are for that moment, but and the other thing is there's lots of false starts, isn't there?
Mm-hmm.
There's lots of signals from the Earth. It gives us seismicity signals. It kind of deforms. It does lots of things, and you think it's about to start. So you say everybody evacuate, and then people will leave, and then nothing happened, and then they all get kind of pissed because somebody looted their house. Yeah.
But there's that quote: "Civilization exists by geological consent, subject to change without notice."
Yeah, yes, exactly. Yes, that is. And in terms of climate change, that's I also, I used to live I lived in Wyoming for years, and I would think about Yellowstone every once in a while. It would come up in the back of my mind, and I'm like, well, at least I'm close enough that I'll just be dead. I won't have to worry about the eventual fallout and epidemic starvation that would occur if the Yellowstone volcano went off. That's an interesting glass half full take on Yellowstone. At least I'll be dead quickly. Right.
Well, I mean, you look at you were just in Texas recently for a conference, and I mean, if the models that predict the eruption, or if the data we have from previous eruptions is correct, I mean, that the debris or the ash cloud reached Texas.
Yeah.
That's just a huge, huge explosion.
No, that's true.
And you get some good seismic data, though.
Yeah, exactly. A natural source. Yeah, but I mean, even those things, they're kind of really scary when you see a big ash cloud settling over, San Antonio. But again, trying to communicate that to the public about, and also scientists telling people what they know and what they think they know and what they don't know, because are you not always treading a really fine line between being an expert but not knowing all the answers?
Well, scientists, I think we're very good at talking to each other about uncertainty, and it's a thing we're all comfortable with. And Tom, maybe you can speak to this too. But I think the general public doesn't understand that our comfort with uncertainty doesn't mean we don't also have an expertise in what we're talking about.
Yeah, I think that's a good point. I mean, when you speak about uncertainty, it's generally assumed that you don't trust your results, or there's some essentially that you don't trust your results, or that that it's not a foregone conclusion. And I think we interpret it differently than the general audience does.
Do you find that even other working scientists are affected by the amount of data you can bring to bear on your projects? Because I know as a paleontologist, when I'm looking at sample sizes, I'm usually looking at N of less than 12, 12 if it's a very robust. And so has thinking more about the big data world of the internet and all these connected databases and stuff changed the way you feel about, or at least changed the way you were able to present your science or get other scientists involved?
I think it's changed the way we've been able to present results. As you mentioned, we can actually bring a lot more data to bear on the problem than we could before. One area that we're still struggling with, at least in the computational sciences, is how to have the computer kind of present its work and kind of check its answer. And explainability is still an area that needs some work. And so the computer can give you a recommendation. It can look at all these other data sets that we might not have been able to look at before. But explaining to the researcher how it did what it did and why it's recommending what it's recommending, or why it's concluding what it's concluding, we still need to work on that. And so presenting the results of these data science algorithms to geoscientists is still somewhat of a challenge.
And as we kind of wrap up this segment, is there a version of this GeoLink program you mentioned available to geoscientists publicly, or is it still private or proprietary?
There is a version available. It's at geolink.org. I would say it's still it is a concluded project, but it was a proof of concept project. So it's still a bit rudimentary and rough around the edge, but it is there, and scientists can go take a look and play around with it.
Cool, yeah, because I know we do have scientists that listen, so there might be people out there for whom that sounds like a tool that they could make use of. Are there any other aspects of your research? It's I kind of tried to give you both time to talk about things, but did I overlook anything huge in either of your research programs, or things that you really wanted to talk about before we move on to the next segment?
No, not really. I had a quick question for Tom, if I'm allowed to.
Yeah, let's do it.
Is one of the problems with communicating kind of computer-derived conclusions that the computer it doesn't err, and it doesn't kind of do all the things we do when we write papers and stand on a stage? So, the data imply this, or, we use all these sorts of terms. Is that an issue, do you think, for communicating those results?
Yeah, I think that's certainly an aspect of it. It's, in the computing sense, it's much more, I want to say less ambiguous. I don't know if that's, or maybe more strict is a better way of saying it, is that we put very formal relationships and connections in a form that a computer can work with. So saying things like, well, the data would seem to imply this, or they would suggest that, are kind of difficult, if not impossible in some cases, to encode in a form that a computer can work with.
Okay.
And in some other cases, particularly in the data sciences, the computer will go through and it's more of a statistics and probabilistic approach, and it will find the most optimal, it's an optimization problem in finding what are the best parameters to make the input examples that I can match up with the outputs that have been given.
Okay.
And so it'll tell you, well, this is the most optimal, these are the most optimal parameters to use, but explaining how it got to those, that optimization and the search process it went through is, putting that into human readable form is not an easy,
Yeah. Okay, yeah. It's I've always, like I say, we struggle with very soft observations we make with some of the data types we use. I just thought, with computers, the numerics would be kind of easier to communicate. But I guess if you say we're 65% certain there's going to be this, that is equally as difficult for somebody to understand as saying it maybe will happen.
It is tricky. I mean, I get annoyed with myself when I have to write all the wiggle words in, and I know that they're needed because I have small sample sizes, and it can be ecological data, which has so many confounding variables. I have to rely on statistics to tell me if what I'm seeing is potentially true or not. And so, I have this added layer of, well, I hope the data is good data, but I'm also hoping that the statistical analyses that I chose to use were the best suited to answer the question, and then still write it in a way that says something,
Yeah.
In the on the semantics side of things, at least in that area of data science, it works with deduction. And so we put these logical statements into a form that a computer can work with, and then the computer will go through a process of mathematical deduction to infer what additional statements would be true. And so you can imagine if you're working with kind of these real world examples where you have hundreds of millions of statements for the computer to work with, one or two false statements somewhere in there can lead to some really interesting conclusions that the computer, it followed the math, so it thinks, well, these are logical conclusions that I've arrived at, but in fact they're false because the original premises were false.
Oh, now you're doing some Dr. Ian Malcolm stuff, right?
Yeah. And we had some really there's been some really humorous examples in that case. Someone was building such a system with some general knowledge, and they asked the computer, where on the moon did the Apollo 11 landing take place? And it had happened that the coordinate systems were input incorrectly. And so they were Earth-based coordinate systems. And so the computer said, well, it took place in Arizona, which all the moon conspiracy theorists love that response. But again, it's, as with much of geosciences, it just happened that we started with some faulty data. And so our conclusions at the end were a bit off.
Oh, crikey.
So we have been to the moon, is what you're saying.
Well, this computer seemed to think we went to Arizona and not to the moon.
Well, I know we've been to Arizona. That I'm sure of. Nobody's questioning whether or not there are people in Arizona. It's whether or not people have gone to the moon. That's funny. I mean, when I was learning to code, one of the things you're told is that, like, what is it? You're essentially writing a screenplay, but remember the computers are terrible actors.
I heard that one.
Yeah, because they'll do exactly what you say, and so it's I guess you're like the George Lucas of directing at that point.
Yes,
you're just you get a very wooden performance.
There's that computer science saying that the computer will do what you tell it to do, not what you want it to do.
Ah, yes, that's another one that I remember seeing. Yep. Well, as we know, there's only 10 types of people in the world: those that understand binary and those that don't.
Oh.
All right, on that dad joke, I think we can move on to the next segment. And so, after a brief musical interlude, I will be back to ask you both what we are drinking.
See, now I just wanna live forever and ever. Maybe it's the last night. Maybe it's the last night. When the world was designed with this and that, I was young, didn't know to hold it back. Now we here in the world, something else. We could leave any day and call for help. We were gods, nobody was above me. The A on my chest like adultery.
A on my chest, put your fist up. The A on my chest like a chipmunk. Alvin, Theodore, breathe in, breathe out. Me and more, breathe in, breathe out. Never mind, it was time. Number 9, lies, feline with a death wish. Eat right didn't help shit. No name on the guest list. Hold on with the destiny.
I don't wanna see and never know, and never know, and never. See now I just wanna live forever and ever.
Well, it would not be an episode of Science Sort of if we did not also talk about what we're drinking, because as much as we've chatted a little bit about outreach tactics in the first segment of the show, one of my favorite outreach tactics is humanization of scientists. We are people, and as people, we need to consume fluids to stay alive, and sometimes those fluids are consumed for fun, as well as satiation, I guess would be a word. So Chris, it's a little bit later for you, so I'll go ahead and ask you first. What are you drinking?
I can justifiably say I'm drinking, right? Because it's 9:15 here in the UK, whereas you two...
a bit earlier.
Yeah, no, I am drinking something called a Camden Hells Lager. And Camden, if you've never been to London, is a kind of area of North London famous for its market, Camden Market.
I think I have been there.
Have you been there? Yeah, it's kind of a famous tourist spot. And
I went to a brewery in that area, so maybe I've even been to
maybe you went to the Camden Brewery. Yeah, it's brewed 5 miles away from where I'm sitting right now, and it's.
I know I had a meat pie, which was delightful.
Yeah, I mean, what was in? Can I ask you what was in the meat pie? Because that's a very peculiar British phenomenon of an unspecified piece of meat in a pie. It was
boar, but I only knew that because of the label. There was nothing about it that actually I would have not been able to tell that it was boar just eating it. There was a lot more gelatin in it than I was anticipating. That was the thing I remember about it, was that it felt like there was as much meat as there was gelatin.
Yeah, that happens, I can imagine. But normally, Camden's a fairly hip, cool place, very mixed. So I don't normally drink lager. I normally drink bitter, so kind of browner, darker beers. But this Camden Hells Lager is pretty nice, so I'm going to open it now, if that's all right. Am I allowed to open it? Is that good?
Yeah, please. No, we like the Foley. And I actually have been there. I've been to that brewery.
Yeah, no, I've never been, but it's kind of taken off in the last couple of years. So that's what I'm drinking right now. It's very nice.
I had their pale ale when I was there. I have not had the Hells.
Yeah, the pale ale is very good from there as well.
Well, Tom, what about you? What are you having this afternoon?
I'm having a triple hopped IPA that I brewed myself.
Oh, wow. He couldn't get any greater, right?
Yeah, you couldn't teach a computer how to brew it for you?
Yeah, there you go. That'll be my next project.
The brewputer.
Yes.
I've done a little bit of home brewing, but not a ton. What is triple hopping? How does that work?
So I am a bit of a novice home brewer. I'm at the partial mash phase, which is kind of halfway between brewing from
extract versus whole grain.
Exactly, right. So, thank you. I'm kind of right in the middle. So so triple hopped is so at 3 points during the brewing process, we throw in some additional hops.
Wow.
Interesting.
Usually spread out by about a half hour or so.
So in addition to the normal hopping process, which would usually be some bittering hops during the boil and then some finishing hops during the ferment, you're saying 3 more times beyond that, hops are being added.
Yeah, so during the boil, we start off with some initial bittering hops, and then at about half-hour intervals, twice more, add in some more hops, and then leave all 3 bags of hops in there during the fermentation process.
And do you taste it in between so you can see how the additional hops continue to change the flavor?
Actually, this time I didn't. No, this time I just let it go until it was finished.
How'd it come out?
It actually really well. I'm actually surprised myself this time around. It's pretty good brew.
What sort of percentage does it get?
This one's about 4.7.
Oh, right, okay, very civilized.
Yes, sessionable. That's nice. There's been a trend here in the States towards having more sessionable beers since the craft brew movement, when it first took off, it very quickly went big and was making a lot of very big and boozy beers. And so there's a little bit of a pushback to make it so that you can actually have more than 1 or 2 without being on the ground. I think a good thing. That's very cool. I'm having it's called the Creedence Pilsner from Crazy Mountain Brewing Company, which I don't actually know where that is. I guess it's in Colorado. It's a Colorado beer, but I got it at my local local beer shop that I like, because I also needed something sessionable and drinkable for some Dungeons and Dragons yesterday. So I still had a few left over, and I'm having one with you.
What happens if you're drunk in charge of a Dungeons and Dragons game?
I wasn't the DM though. I'm just a player. I'm but a character in the world.
Oh, I see.
And I don't think my character is drunk just because I am. I don't think that's the way it works. I think
it doesn't carry over like that.
No, I think my character would have to drink something in the game, and my character's on the young side, so I don't think he's probably much of a drinker. And he's kind of he's a martial artist type, so he wants to embodies a temper. Yeah. Well, very cool. Well, I don't have a good transition in mind, so I did want to ask you, Tom. Do you name your homebrew?
That's a great question, because when I first started homebrewing, I tried to come up with all kind of quirky, like geoscience or computer science and theme names, and something that would somehow tie in with the particular brew. And then my drinking buddies, who are not scientists, kind of looked at me funny and said, "Just stop doing that." So this one, I grabbed this particular recipe off of one of the online beer forums, and I'm just reusing the name that they suggested.
Which is the triple... Oh, no, go ahead.
Yeah, it's the Dry River Rye IPA.
Oh, so it's got some rye in there, too.
Yeah.
Nice. See, if you wanted to go with a geology-themed one, I know that there's a Belgian type of beer called a triple, but I also think because it's a triple hopped, you could call it a triple junction.
Oh, I like that.
The meeting of 3 different hops.
Wow, that is impressive. Like, you probably don't send this podcast out because you probably want to write that first. Before.
This is your audio copyright. Copyright on the Rock and Science.
Well, I currently have an oatmeal stout in the beer fridge. It should be ready in a couple weeks. You guys have any
one of my wife's
recommendations?
Favorite styles of beer.
Oh.
A geologic style for an oatmeal stout.
Heavy flow. Would that work?
Because you have to grind the oats, right? So what's that type of soil that forms in between faults?
Gouge. A gouge is the name. A gouge or a breccia or something.
Breccia. Oh, breccia.
You could call it, yeah. Oh, yeah. A gouge is a good geological word. So you could call it Tom's Dark Gouge.
Okay, that could work.
I don't know. Yeah, that might work. I'm copywriting that
now. We'll keep working on that one. And I think, I don't know if either of you guys use the site Untapped. It's like a check into your beer that you're drinking thing, but you can actually add your homebrew to that site. And so people can check into it if you give out bottles or whatever to your friends.
Ah, right. Okay, I've not seen that.
Yeah.
Well, I'm going to have to get copyright permission from Chris before I can post it.
I'm sure he'll charge a very reasonable rate. He might not be able to enforce it from the UK, especially now that they're out of the EU. So
I'll have a CC BY license on it, Tom, and then you can have it.
So you just have to worry about distributing it internationally.
Yeah.
If you wanted to publish the recipe, but the recipe wasn't a recipe for beer, but actually a paper about geology, maybe you would use the EarthArXiv, which is what we're going to talk about next. Very belabored transition.
That's beautiful.
Number in the sand, right next to an empty can. Old number 7, Jack is back again. And the voice goes round and round. I would take the bridge, but I can't forget the sound that
London Bridge is falling down, falling down. And if it don't stop falling, then all of us will drown. Then we'll crash, right down again. Oh, we'll crash, right down again. I'll be coming up when the sun goes down, rolling like a rock till I hit the ground, running from the law but I can't be found, only my God can track me down. I'll be coming up when the sun...
The main reason that I actually wanted to get both of you on the show is that you are pushing a new preprint publishing solution for geoscientists called EarthArXiv, in the vein of the original archive, which is a physics and astronomy preprint server. We've talked about it before because our resident physicist Ben Tippett has published to that system before, and we're starting to see that system pop up for other types of science. And so you guys have one that you were part of the development and steering committee for and are now trying to get people to use. So I think there's a lot to talk about here. I think, especially since not everyone who listens to this show is a scientist, I think we got to start from the beginning in terms of like, we got to talk about what a preprint is and then go from there. So can either of you touch on what a preprint is and why it's relevant to scientific publishing?
Yeah, go ahead, Tom. You've kind of answered this one before very well.
Okay, sure. So a preprint is a scientific manuscript, a paper of sorts that has not gone through the formal peer review process. So you haven't yet sent it off to a journal to be accepted for publication, and it hasn't yet been looked at by any reviewers in the field for peer review. And the idea with a preprint server, which is a computational infrastructure that hosts preprint papers, is that you can get your paper out either in a preliminary stage so that you can get feedback from the community, which may help revise your paper for ultimate submission to a journal for formal peer review. And just to note, like, this is not instead of peer review, which is what the typical path for scientific publication. This is meant to be in addition to and to complement the formal peer review process. So you can get your research out there earlier. Once you upload it to a preprint server, it's immediately time-stamped. It's immediately given a unique identifier. It's given a DOI. And you can assign a license to it. Like the typical one is the Creative Commons CC BY license. So you immediately have a claim to that research, and then because it has a DOI, you can cite it in other research you're doing. You might cite it in a funding proposal that you're sending off to an organization. You can cite it in other papers, because as we all know, the formal peer review process takes months, if not years, and so during that time, a lot of great research is really lost to other researchers. We have no way of citing it and acknowledging it. And so if we can get it out there early, we have a means of leveraging it, and we can also simultaneously get additional feedback from the community that could then be leveraged into revisions and a final version that would go off to a journal.
That's a great explanation. And I guess the question is why it seems like a preprint server might be adding more steps to the process, which might make it take even longer. So what's the argument that this is actually benefiting the overall scientific process? I mean, I know you said that like it means that it can be cited before it's peer reviewed, but isn't the whole point of peer review to perform a check against the data before it goes out to be citable?
Yeah, I think in the preprint scenario, it's immediately open access and free to everyone. So yeah, I think, and correct me if you disagree, but I feel like, the preprint scenario allows you to get much more feedback and much more potential for revising the paper and making it better than you would through the formal peer review.
Yeah, I completely agree with you, Tom, where you're going with that. I think like the flip side of that, which is a reasonable concern about the lengthening of the process, is that actually by getting some feedback earlier, you may actually have a more optimized manuscript that then gets off to the journal and doesn't get kind of terrorized in review. So it can work the other way.
I like the idea of it being a more collaborative way to do science. I think maybe that is part of the culture of different disciplines within geology, because I know within paleontology, there's actually a lot of suspicion and fear of getting spooked. And I mean, that suspicion comes from, I would hope that in the modern world, it's better, but I know I've had friends who've had things like data stolen and research scooped and things like that. But, paleontology also has a long history of being terrible at that sort of thing. If you just look at the bone wars of the 1860s and 70s, where trains were literally blown up because they had the rivals' fossils in them. So, like, paleontologists have gone so far as dynamiting fossils for the exclusivity of themselves. So how do you talk down someone who has a lot of fear or hesitation when it comes to putting data out there before it's gone through the traditional formal process?
Well, I think, it's certainly a valid concern. Yes, putting anything out there for everyone to have access to, it's, there's certainly that potential for scooping. We think that having the ability to give it a DOI, to give the preprint a DOI as it's published, to timestamp it, to put your name and your mark on it, hopefully helps alleviate that. I don't think we're going to eliminate scooping, but if someone were to do that, it seems fairly easy to go back to a preprint server and say, look, there's my paper and here's the date and time that I uploaded it. Clearly I had that work first.
Yeah, I was going to say, Tom, as well, the scientists are many things, and one of those is kind of protective of their reputation. So scooping and kind of poor conduct of any sort is hugely frowned upon. So I think it's one of the things people want to protect along. Yeah, as well as protecting their idea and data, they want to protect their reputation. So I think and scooping's quite rare, at least in the area which I work in. I don't know about you, Tom.
Yeah, no, I agree. I think it's fairly rare. And, as you were touching on, as a scientist, you only get one reputation. And if
That's true.
If you were to, ruin that through scooping, it's fairly, I don't want to say fairly easy, but I think the mechanisms are in place to point out when and where that does occur. And, as Chris was mentioning, the consequences of that are pretty severe in our field. And so we're hoping that it will be a self-correcting problem.
And I think we talked about this, Tom and I, the other day, but some people are built to be fearful of new things, and maybe, they're just quite secretive by design. And whereas some people are completely the opposite, they actively seek out collaborations and actively share because they, every 1 in 10 times you get burnt, 9 of those times something wonderful might arise from it. So, the former, the people who naturally wouldn't want to do this because they think that, people might be out to get them in some way, it might be impossible to convince them that this isn't going to happen. But we're not guaranteeing it, right, Tom? I mean, we're not saying to people, you will not be scooped. We're kind of saying there are these benefits, so erring on the positive things about preprint servers and EarthArXiv.
Yeah, I agree with Chris. I don't think we're not proposing that we're going to solve the problem, and that certainly is an underlying concern with preprint servers. But we think that the benefits certainly outweigh the negatives, and it's something that hopefully will resolve itself as we move along. One
of the ideas behind this is, I understand, to also promote open access, right? And so how do the journals respond if you are submitting to a journal that's not open access, which a lot of journals these days have open access options, but they cost a lot of money, and so not everyone can afford that, or it just isn't in their interest for whatever reason. And are journals hesitant to publish something if it's already been put out as a preprint?
I'll jump in there. So yes and no. So what's been really interesting in our experience so far with EarthArXiv and historically with Archive, all sorts of preprint servers, is that there's quite a lot of variability in what a classic journal considers prior publication. So Nature, Science, many of the Elsevier journals, EGU, there's AGU as well, which we might talk about later, but a lot of them view they don't view something being on a preprint as prior publication. So they, in AGU's case, they actively encourage it, right? Because they're going to be bringing out their own preprint server soon. But some other publishers just say it's cool, they don't mind because they think, presumably a better product may arrive at the door of their journal if it's been through some sort of informal peer review before going through formal peer review. What we've noticed, and Tom, it'd be good to get your view on this, but the societies, so journals ran by professional societies, seem to be less attuned and less willing to allow preprints to be submitted to their journal, so they view preprints as prior publication. That's something that I've sort of seen, at least in the areas I work in Earth Sciences. I don't know about you, Tom, in your field, what your experience has been so far.
Yeah, no, I would agree with that assessment. I think we've also noticed that, kind of getting this project off the ground, that this concept is really, although preprints have been around for quite a while, and EarthArXiv kind of paving the way, that just the notion of preprints is still really new within the geoscientists and to many geosciences and geoscience publishers. And so a lot of publishers aren't even really sure what their own policies on preprints are. And so, it's kind of been a work in progress and really kind of building up an understanding of how the different publishing houses, who is receptive to preprints and who isn't, and what you can do and where.
I mean, Tom, we've kind of resorted to asking people on Twitter what their preprint policy is and getting responses. I mean, that's where we're at the moment, is this amazingly dynamic sort of landscape of professional societies largely sort of on the hoof deciding what their preprint policy is. Because there's obvious issues with competitiveness between those journals, their related journals, being attractive to scientists, isn't there? Because if you don't accept preprints, then somebody might say, well, I want to go the preprint route, and then I want to submit it to a classic journal, but because you've cut me off, I'm going to go somewhere else. So that, those publishers or those professional societies are having to kind of make some fairly rapid decisions.
Is there a policy that you would feel is optimal based on your experiences building a preprint server, or what do you guys think about how you would prefer journals handle things?
I mean, yeah, I think they should accept them. I mean, it's not just journals that are accepting preprints, it's also major funding agencies are allowing it. And in fact, there was a bunch of traffic maybe a month ago now about some big institutions in the US and, all around the world who were encouraging people who are applying for jobs to actually include preprints in their packs.
Oh, wow. So
it's not a kind of, it's not just a few idiots like, Tom and I sort of acting as cheerleaders and kind of like championing this. This is sort of starting to seep, it feels like, into the way of doing business, Tom. I mean, have you seen that as well in the US?
Yeah, I have certainly seen it. Some of the major funders are accepting preprints. It's been encouraged in a couple job applications that I've seen. And I think as long as we designate that this is a preprint and it hasn't gone through the formal peer review process, I think scientists are a smart bunch, and they're sophisticated enough to understand how to use a preprint and where and under what conditions a preprint is appropriate to cite or to leverage the results from. And so I think, as Chris was mentioning, I think the more places we can get these in, I think the more efficient we can make science, the more we can leverage scientific results, and the scientific community will they're smart enough to understand how to use these things and how they can reference them.
Efficiency would be good. I think that will help when the robots take over if we've already made the process more efficient. Okay, so let's pretend, for the sake of argument, that I'm a scientist and I want to add a preprint. So what do I do?
For EarthArXiv, you kind of wander onto our website, eartharchive.org, ARXIV. I think 9 out of 10 people can't pronounce it whenever I speak to them, but they're all learning.
Because it's the Greek symbol for Chi, I think, or something like that.
Tom, do you know why archive was originally spelled like that? It looks cool.
Other than the coolness factor, no, I don't know.
Because there's a test in statistics called the chi-squared test, and that's denoted with an X that's been squared, superscript 2.
Yeah.
So I was assumed that there was a Greek letter called Chi that looked like an X. That was my assumption for why the archive.
I thought somebody clever at Cornell or may have come up with it. But you basically crash onto the website. You can then just go to add your preprint and then just add some metadata, so title, abstract, some tags that are relevant to that'll help the discoverability of your work via different indexing services and in EarthArXiv in between the different preprint servers run by Open Science Framework. And you are done, and then upload the document. It can be in a number of different formats, and then you're pretty much done. I mean, it takes 5 minutes, 10 minutes.
That's awesome.
Wow. Yeah,
we're trying to make it as simple and painless of a process as we could. And the only other thing I would add to that is that we are encouraging connecting your manuscript to any data or software that you might have associated with the research. So the open science framework that we're leveraging with EarthArXiv allows you to connect to GitHub, which is a software versioning repository. You can connect to things like Google Drive and Dropbox if you have data sets that you want to link to. And so we kind of think, capturing the data and the software will, help out with the open access and helps with reproducibility and really capturing the entire scientific process that went into creating that manuscript.
So I do a little bit of coding for the science that I do, but I mostly write script in R, and then I don't tend to do a lot of collaborative code writing, so I'm not on GitHub. I tried to learn it once, and it was terrible. I found the whole thing very confusing and counterintuitive, and GitHub and I are not friends right now. So, for me, would it just be like a statement of I did my statistics in R and here's the code, or?
Yeah, I would just say, the more...
It's that simple?
Yeah, it's that simple. I mean, if you don't use any of those external tools, The Open Science Framework does provide some disk space of its own. So when you upload a manuscript, you're assigned some disk space. And yeah, if you just want to simply upload some R code or a data file, any additional resources that you want to tag in your manuscript would certainly be acceptable. And the more you could help out the person reading your paper so that they might reproduce the work, the better. Interesting.
So we briefly mentioned that AGU, the American Geophysical Union, which I guess, full disclosure, I'm a member. I don't know if that.
let's end this.
Yeah.
I don't consider myself like a journalist, but I suppose ethics are a thing I should try to pretend to do. They're developing something. They announced it in September. And in your mind, is this a competitor or is it a rising tide lifts all ships? Like, what's the attitude as a rival or other preprint guys?
You want to take that one, Chris?
Yeah, I mean, I think it's the latter. I definitely think it's the rising tide and lifts the ships. For a nanosecond, when I saw their press release and, it kind of became aware of ESOR that they were formally going ahead with it, having known that there'd been discussions probably over the last year or more about AGU getting into the preprint game. For a nanosecond, I thought, oh, Christ, this is a big, big beast and it's coming along with all the infrastructure and power and everything. And then, within literally seconds, I was like, hold on a second. This is a big organization. They influence a lot of people. They've clearly identified the power of, or the value of preprints and preprint servers.
Are they officially the largest geoscience? I think they might be the largest geoscience.
I think they must be. Is it like several tens of thousand members? I mean,
yeah, it is. I always, at least once a year at the annual meeting, I try to figure out how many people are in attendance and then make a joke that all of us came together to agree that we're going to keep faking climate change. So it's like, yep, all 14,000 of us managed to come up with the same lie. Not a single person's going to break ranks again for another year.
Exactly. But I really think it added a lot of I don't know, maybe credibility to what we were doing. And, sometimes when you're doing something which is new and a bit edgy and there's doubters, understandably, when somebody else comes along and says, we think this is a really good idea, it gives you a little positive, it gives you a boost and you think, okay. And so the competitive element, if we are sitting here in a year's time, me and Tom, with EarthArXiv remaining at 130 preprints and postprints because everybody goes over to use ESOR, then at least we could say we were part of a movement.
And I'm guessing you can't really submit to both, or you shouldn't, because you get the whole DOI thing. You want there to just be one digital object identifier per manuscript out there. I think that makes sense.
Yeah, I don't know if you thought about that, Tom. I think most people probably would.
I think most people probably would just submit to one. There have been some, and this is very preliminary, but there's been a few discussions about what it might look like in the future, and is it not necessarily submitting to another one and getting a different DOI, but could it somehow be searchable across the different platforms? Those kinds of things. So I don't know. Maybe somewhere down the road you'll be able to do one big search across all of these systems. But yeah.
It sounds like the kind of tool you yourself would be well equipped to build.
Coincidentally.
Yeah.
If anything, AGU needs to hire you, right? That's funny. And it's free. I guess we didn't point that out, right?
Completely
for
free.
Scientists, which journals are not. I don't know how many people realize this, but scientists actually pay to be published in the journal, and then the journal turns around and sells that paper to other researchers or institutions. So journals have somehow figured out a way to get the people providing the product to pay them for the service and then to sell the product.
Yeah, but actually, I mean, what I would say in fairness to some of the major publishers who I've had fairly active discussions in inverted commas with, in quite a lot of journals, it's actually free to publish. Okay, so you can turn up to a Elsevier or a Wiley journal or Springer and get your paper published for free, right? So you don't pay for the gold open access charge, you don't go over 10 pages, and you don't have any color figures or whatever, and you basically get that published for free. Now, that is still sold back to your library or to other libraries as part of a subscription. So, as and
you also lose the copyright.
You lose the copyright, which, this is a bigger and broader discussion for another podcast, perhaps. But people are willing to lose copyright because of the egotistical gains and also the actual material gains. If you want to make tenure or get a job, you want to be publishing in certain journals. It's an interesting problem, isn't it? Because even though it's nonsense and some of the things.
The The system is definitely incentivized. We'd be hurt if we tried to not, play the game that is needed to be played.
Yeah. But I think with things like archive and preprint servers and some of the other things that are going on in the open access movement and the, let's say, the louder voice of the ECRs, the early career researchers, which is the thing that excites me. I don't think I qualify as an ECR anymore, but like... What's
an ECR?
An early career researcher.
Oh, okay. Gotcha.
So that, in my view, that goes all the way from MSCs, all the way to, I don't know, what would you say, pre-tenure, first 10-year assistant, maybe even associate professor in the US system. So, I'm kind of just across that thing. So I'd like to think, with that, they've got a louder voice. They feel more empowered. They want to change. There's a hunger there. Maybe it was always there. I don't know because I haven't been around all the time. So I think that might be a catalyst for change.
One hopes.
Yeah.
Yeah, and one additional thing that you could do with EarthArXiv, I know we've been focusing a lot on preprints, but some journals do allow what are called postprints, which means the author's version of record you can then post to a preprint server, even though it's been accepted and published in a scientific journal. And so this is an additional way to help get your work out there. There's some early career researchers, some researchers in developing countries who just cannot afford the subscription fees that, some libraries that can't afford the subscription fees that these journals are charging. And so if you can still publish in a journal, but then post a copy on EarthArXiv so that others can have free access to it, it has been shown to really help accelerate some access to the work.
I think that is actually an amazing point that I've never heard made about any of these preprint servers before. And so I'm glad you said something about that because, yeah, it's really hard. I work in countries for the research that I do that are, you could maybe call them developing countries. I don't know if that's like a problematic term or not. But essentially, there's limited resources relative to what I have access to here in the US. And so the burden of trying to be a scientist and while staying in your home country and not having to come to the States and get a degree and then try to move back and make it work, that's a significant hurdle. And so the more barriers to entry you can remove, the more people you're going to empower to be scientists, and that's going to generate more data and hopefully generate more good science.
Yeah, totally. I mean, it never fails to amaze me how many requests I get and everybody I speak to gets on things like ResearchGate, who have been in the news recently. But It's amazing. I just sit there and I'm thinking, I just press the button and all the papers are there for me at Imperial College, this big fancy university. And then there's all these people saying, "Chris, can I have your paper from 2003 because I can't get it?" I'm like, why not?
Right. And so for people who aren't scientists, to kind of explain, when you're a member of an institution like a big university, the library is paying all these journals and journal companies for subscriptions to all these journals. So we get institutional access through our library. So when I'm off campus, I still have to log in through the library portal to get into all these journals. And then there's this other website called ResearchGate, which is essentially like a social network for scientists, kind of a Facebook type thing. And you can upload your papers there for people to then download for free, getting around that sort of institutional subscription model. And they just got hit with, was it a cease and desist or a takedown order?
Takedowns. Yeah.
Yeah. So they got hit with a big takedown order because all these papers, even though it's the authors themselves putting the papers on ResearchGate, the authors no longer own the copyright. And so it's not their material to distribute. So that's tricky.
Yeah. But again, it's one of these things that is maybe serving to sharpen the mind of academics who are so busy doing the science and doing their admin and their teaching. When that copyright form comes through, says transfer your copyright to us, or ResearchGate turns up and says upload your paper, and then suddenly you get a takedown notice or you get a slap on the wrist. It's good, right? I mean, we've got to be educated about what we're giving away, what we are allowed to do, what we aren't allowed to do, what power we have. I think it's exciting times.
Yeah, I think it's helping scientists recognize that their work has value, not just because they care about it, but there actually is economic value to the work.
Yeah.
Well, is there anything else that people need to know about the EarthArXiv, even if they're just kind of generally interested in this stuff, or maybe even as a working scientist? What's the kind of take-home message?
Use it. It's brilliant, Tom.
Yeah. You nailed it. That's it.
You nailed it.
Even if you're just a member, even if you're not a scientist, you can still go look at the papers, right?
Yeah, totally. I mean, one thing that's probably worth saying is this is a very community-based and led effort. So, it's supported by Open Science, the Open Science Framework infrastructure. So, it's a non-profit, EarthArXiv's non-profit. Tom and I have got like a million other things to do, like homebrew, and sort of, we've got loads of other things to do, and we and all the people who've been, and it's important to point out, it's not just Tom and I. There's a big group of people who've been behind this effort to get this thing going, and we're all putting in voluntary effort to make it happen. So I think, going back to your, kind of the discussion we just had about these big publishers, this is one way of the community trying to build something for the community to use, which we think long term may have benefit and give some sort of power back to the academic. Probably the best way of saying it.
Yeah, no, I'm like having power. It's a new feeling, but I'll try it.
Yeah, it's been absolutely amazing to see how the worldwide community of academics has come together around this idea. And I mean, as Chris mentioned, it's just been all volunteer efforts. We've been using free tools and Twitter and Facebook, and there's a Slack tool for communications, and just seeing hundreds of people from around the world just pitch in on their ideas for preprints and what they'd like to see, and volunteer to promote this to their respective communities. It's been an amazing grassroots efforts, and it's been a lot of fun to be a part of and see how it's kind of emerged.
I tried to get my lab on Slack, and it took for a little bit, but then kind of people stopped using it, and so I was sad because I think Slack is an amazing tool for. They're not sponsor of the show or anything. But free plug. We use it. We use it to do the show, the podcast, and so I really like it.
I can tell you, 4 months ago, Chris had no idea what Slack was, and now he's an expert. He's on it every single day, and so that is one of the big takeaways from EarthArXiv. That's
even if the whole thing goes down tomorrow, Chris has sent 25 Slack messages to the wrong people.
But it's so much better than email. Like, that's the whole thing is, they joke about it being an email replacement, and it's so much nicer that, it only breaks down when I have to email or text the people on my team, hey, you need to be checking the Slack more.
Yeah.
That's the only problem. Oh, it's funny. Yeah. There was this thing, Google Wave. Nobody seems to remember this, so I'm hoping that, I other friends of mine used it. We used it in the early days of this podcast. So this podcast has been going since 2009, and Google Wave came out in 2009, and it was essentially like Google's version of Slack. And then a few years in, they stopped supporting it and it went away, and it was really sad for us because it was the best tool we'd found for managing the show, and it was great. And then it wasn't until Slack came out where they essentially redid it from scratch, and so no one remembers. And so it was, I feel like a crazy person talking about it, but it was awesome. You guys are both active on social media, so I want to make sure before I let you go that people know where they can follow you and follow the work. So do you want to plug your various websites and Twitter handles and whatever it is you want to put out there?
Yeah, so I am on Twitter at Size Matters, so I should just explain where that name comes from before I get a torrent of abuse from people. So Size, S...
You're not just mispronouncing the Spanish word for six.
No, not that I'm aware of. I probably am.
That's how it's spelled.
No, it's Size, S-E-I-S, so as in seismic, so Size_matters. So that's me, and yeah, I tweet about EarthArXiv, I tweet about lots of different science stuff and academic-y stuff. So, if anybody wants to follow me and interact, that'd be great.
And when your kids are skeptical of dinosaurs.
That helps. That definitely helps.
You and I first started. Yeah, so I've been wanting to have you on the show for a while, and we didn't even really talk about that much. But
you should hit me up again, and we can talk about it again. And I'll put Olive, my eldest daughter, on because she's obsessed by dinosaurs. So she actually asked me the other day whether she could get a chicken because then she could tell her friend she had a dinosaur, which I thought was absolutely awesome.
We should definitely set up a dinosaur Q&A segment. I know I'm not a dinosaur researcher. I usually say I'm not a dinosaur person. I'm a mammal person, which is true in multiple ways. But I know some dinosaur people, so we can make this happen for you.
Thank you.
And Tom, what about you? Where can people follow you in the World Wide Web?
So Twitter's probably the best place for me as well. I am at T Narock, TNAROCK on Twitter. We also have at EarthArXiv account on Twitter, And if anyone's so inclined, there's the EarthArXiv.org, which is where you can upload preprints, and we have a companion GitHub site at EarthArXiv.github.io, which is all kinds of background material and related resources on preprints for those who might want to check that out.
Your Twitter handle actually confused me for a little bit because it's geology. I thought rock was its own word. So I was like, what is TNA? Like, other than the inappropriate acronym, like, what is he trying to,
Well, when you're probably familiar with the actor, The Rock?
Yeah.
Yes.
Yeah. So when I first started here at the university and I was in the faculty orientation and I was introducing myself, the dean thought that I said The Rock, and she said, yeah, this guy's pretty presumptuous. Introducing himself in front of all the new faculty as The Rock. And it took a couple weeks before we really sorted that out. I was just saying my name.
Yeah.
So now, if you do start a brewery, it can be, do you smell what Narock is brewing?
Yeah. Oh, I like that. We're getting a lot of trademark material from this podcast.
Yeah, we're a free podcast, so this is just a service we want to provide to the community. Scientists, if you need help with your homebrew, come on the show and we'll talk it out.
Yeah.
Well, thank you so much for joining me, both of you, and I appreciate the coordination across an ocean that we were able to pull off to do this, and I really had a great time talking with both of you about the work you've been doing, and I hope scientists and non-scientists alike are interested in it, and maybe this will drive a few submissions to EarthArXiv your way. If people do, is there like a comment form they could, if they submit to EarthArXiv because they heard you on the show, is there like a place for them to say that when they submit?
Is there, Tom?
I don't think we have anything like that on the website, but please do.
Put the podcast in your acknowledgement.
Yeah, reach out to us on Twitter. We'll be happy to share that and let us know that you heard it on the show.
Nice, awesome. Well, thanks again, guys, and have a great evening. And so it was a lot of fun.
Thank you so much for the invitation.
Yeah, thank you. This has been great.
So that was my interview with Christopher Jackson and Tom Narock about their initiative with EarthArXiv, as well as the research they do when they're not trying to revitalize, or I guess, is it a revitalization or just a vitalization of science publishing? If we're still doing it the way we decided to do it the first way, is that a re yet? Well, I'm here with Joe. Joe's going to answer that question right now. Hi, Joe.
Hi.
Did we revitalize it, or are we just vitalized?
I think we're vitalizing a new segment, right? A new area, maybe.
Yeah, I like that. Vitalizing a new sector.
Yeah, there you go.
That's good. It's like if you had a farm and you had different plots, and one plot you just hadn't been trying to grow something cool on, but now you're like, we're going to grow something cool on that.
Yeah, exactly.
We're going to vitalize it with life.
Exactly. No more wildflowers. It's going to be soybeans.
Yeah, screw you, flowers.
Done. I'm tired of collecting government subsidies for those flowers. It's time for some soybeans.
How you doing, man?
I'm well.
Just well?
I'm well. I trying to say well instead of good, right? That's the more proper term, right?
Well, Superman does good.
Does he? Okay. Well, I like Superman, but I prefer Batman.
I mean, he technically does good too. He just does it in a mean way.
Well, in an engineering way. I feel like I relate more to Batman.
Wait, you consider Batman an engineer?
I mean, yeah. I mean, he's a rich guy, mostly. And I guess he has, help.
Are you saying engineers are rich guys?
I'm saying Batman is a rich guy who has lots of techie toys that he likes to tinker with and comes across pseudo-engineer-like in that manner.
He's more of a mechanic.
Yeah, I guess that's true. I guess he has what's-his-name to develop all the stuff for him. Whereas Superman's more kind of, magic, because he has the superpowers, as it were.
But it's science-based superpowers.
Is it, though?
Yeah, he's an alien.
Well,
aliens are made of science. Aliens aren't made of magic.
That's true. Aliens are made of science. It's a good way to look at it.
Another good thing that we should look at is the stuff our listeners send to us.
Hey, that's a good idea.
Let's do that in our next and final segment. That is also next, and that's the PaleoPOW.
Pow! Like in the Batman comics.
And the Superman they all use sound effects. It only got associated with Batman because of the Adam West cartoon. Not cartoon. It was live action, but it felt like a cartoon.
Yeah, it was very cartoony.
All right, see you in the next segment.
Okay, bang, pow!
Appalachian land, in a nation under your command. Did you give it away? Yeah, I gave it away. Did you give it away for free? What would you have us pay? I didn't know that your love was a commodity. What about appreciation? Oh, that depends on your depth and density. What about inflation? Oh, charts and graphs don't mean nothing to me. In your nation, with its worthless.
This is the last segment of the show.
Boom.
And Joe, you're gonna start it because the guy we're doing a thesis for also likes 3D printing. That's my
I like
logic
3D
here.
printing.
You do like 3D printing a lot.
I think that's fair logic.
Better than unfair logic, I guess.
Okay, so my PaleoPOW comes from James P. So James wrote us to say that, well, first of all, he's a patron.
Mm-hmm. He wrote to us as a comment on one of the posts that I put out where I let the patrons know the topics of the episodes that are coming up, so that if you were a patron, you could read up on the stories ahead of time and then be like extra prepared when the episode actually drops.
Right. Which is a pretty awesome little perk. So James P wrote in on the Patreon saying that he just wanted to let us know that this is probably his favorite podcast, and he subscribes to about 90 of them, which is impressive. That's a lot of podcasts.
That is more than I subscribe to, and I think I subscribe to more than anyone else I know. So James is already in first place.
Yeah, I subscribe to a handful, and I can barely keep up.
You have a special set of circumstances.
That's true. 90 is, I feel like, a lot. But, good for you, James. But anyway, so he goes on to explain that he's a freelance design engineer and spends a lot of time doing CAD or machining, just kind of hanging out by himself. So he has lots and lots of times to listen to podcasts or the occasional audiobook. So he thinks we're his favorite. So that's awesome. He goes on to mention that one of the things he's been getting into is scanning and recreating models. So he calls it retopology, RETOPOLOGY, which is actually something I've not heard of. But he says it's basically editing, optimizing, and repair of mesh models, such as those generated by scanning fossils. I think we were talking about scanning fossils.
Does that mean anything to you?
Yeah. So the way 3D models kind of work is they're a collection of effectively, faces. When you scan a 3D object with like a laser scanner, what it's doing is generating a three-dimensional point cloud in a model. So, the laser goes out, it hits the model or the thing you're trying to scan, say it's a fossil. So it shoots a laser out, it hits the fossil skull, it bounces back, and the scanner registers, exactly how far away that point was from the scanner, and it creates that as a point in space in a model, right? It assigns a coordinate to it. And it's doing that really, really fast as you scan across a model such that you can scan something pretty quickly. But what it's doing is just generating a whole lot of individual points. And then you can take software and turn that into a mesh by connecting all those points and then adding surfaces to the mesh so that you have something that actually looks like a solid instead of just a cloud of points. Does that make sense?
This sounds superficially similar to how they build objects in video games.
Yeah, it's very similar to that, except you're starting with a real object rather than in building something for a video game, which is where you're going in and just creating the points on the computer. In this case, you're starting with an actual object using a scanner and just scanning the real object to get those points. Make sense?
Yeah.
So what he does is he can repair those. So one of the problems is when you scan an object, you occasionally get weird returns and you'll get points that are missing, or you could scan a flat table but get some waviness in there, or just like holes in the model. So the service he offers is basically taking your point cloud or your meshed model and basically fixing it so that it looks right or is right, which is pretty cool. He says he's been working with 3D printing since 2004, which is a while back. He's not just some guy with a MakerBot in his garage, as he says. And so...
Yeah, screw those guys.
Hey, I'm one of those guys.
What? Huh?
Dang it.
Don't screw those guys. Those guys are the best.
Yeah. But anyway, that's pretty cool. And it says he's looking to build a new 3D printer, which is a meter square and a 500 millimeters of Z height. So he's going to be able to make some really, really big models, which is pretty awesome. He's thinking.
I would like to know his resolution on that, because so when I scan teeth for my texture analysis, I'm basically generating that same point cloud over a given Z height value, but I'm not ever trying to lay a surface over it because I actually want the variation provided by the point cloud.
Mm-hmm.
And so if I could get a sense of his resolution, we could really get in business.
For the printing or the scanning?
The scanning is what I'm more interested in. Printing is cool too, but for me, the data is in the scan.
Gotcha. Yeah, I'm not sure what the scanners run these days, but I imagine they're pretty good.
Well, the ones I use are essentially confocal microscopes that have been fitted with the right software to do the types of scans I need. So different kind of thing.
Oh, man. Well, so anyway, James P, for being a patron, gets to have a thesis created for him.
Sure does.
So let's see. We were talking about rocks and earth science and stuff.
Machine learning, seismic data, 3D printing.
All right.
AI. We could do AI in there a little bit.
Okay. Yeah. So machine learning is, I think, the better term for instead of AI.
For sounding smarty pants?
Yeah, for sounding smarty pants, which is important in these thesis titles.
I do want to sound smarty pants.
That's really what I live for. I really want to be really smart. So let's say.
Sometimes we like to do the first part of the title and then colon and then the longer part. So what if we did the stability of genius?
Ooh, I like that.
And it's all about machine learning to counteract seismic effects on 3D, and then you give me like a 3D mesh model, 3D printing thing.
Okay. Yeah, stability of genius, use of machine learning and laser scanning to develop.
I think it has to be about offsetting the seismic effects. So essentially, they've developed a thing that's like, if you're in a place where there are seismic shifts happening, even very low level, like very, very low level faulting, they've developed a system that can still counteract that, so the object you're scanning still appears stable. That's what I'm imagining.
Okay.
Because we got to bring in the seismic aspect of it too.
Yeah. So that
to me is the stability part.
Okay. So, okay. Use of machine learning to develop algorithms for controlling tunable mass dampers in skyscrapers. Nice. To counteract seismic effects.
Like really smart ideas.
All right,
now type that into the Slack channel so everyone can hear how loud your keyboard is.
What was the first part?
I don't know, it's recorded. I wasn't listening.
Anyway. Bang.
Perfect.
Yeah.
So thank you, James, for writing in and letting us know a little bit about what it is you do and how that enables you to listen to our podcast amongst the 89 others that you enjoy. So that's pretty awesome.
Amazing.
And thanks for being a patron.
Thanks, James.
Very glad that the Patreon, if people had heard the Patreon had changed its payment model, they changed it back because there was public outcry. Everyone was upset. Here at Science Sort of HQ, we kind of were just like, our patrons are smart enough that if they're going to see this change and they're going to decide on their own whether they're going to keep supporting us at the same level or not, and people need to tweak it up or down to accommodate, that's fine. But that change didn't happen, so everyone should be good.
Not going to lie, I'm still kind of worried about keeping our top spot on James's ranking.
Well, he said probably my favorite. So I feel like he's already hedged.
Stay on top.
I don't know how we stay on top. I mean, we gave him a thesis title. I think that we're good for at least one more episode.
It's true. Good point. It's a good point.
All right, so our next piece of feedback, my PaleoPOW this week, is a type of feedback that we hadn't gotten a lot of in the past little bit, but there have been like 3 or 4 that have come in recently, and that's a voicemail. So I think people have, we spent the entire last year, 2017, calling our representatives to tell them not to kill us or tax us or whatever it is they were up to that week.
It's been a rough year.
So I think people have learned to use their phones again. And so they've been calling 312 PaleoPOWs at 312-725-3672. And we have one of those, and Joe and I are going to listen to it right now.
Hey, PaleoPOWs, this is Baylor. I was just calling to give you all a shout out for being my favorite podcast. I've listened through all y'all's backlog once. I'm listening through it again. You'll probably get stuff like that all the time, but I just really love how chill y'all are. Talking science, talking beer, even though I don't drink. But hey, it's good fun. You have a great time. Bye.
Tell you what, man.
Tell it to me.
Baylor's got something on James, too, for dedication. Listen to the entire backlog twice. That's pretty solid.
Yeah, James, game on.
I think Baylor and James are going to have a competition here.
Baylor also, he called us really chill guys. Baylor also sounds like a really chill guy.
Baylor sounds like a very chill guy.
Also, props for the correct usage of all y'all. That's, if you don't come into that with confidence that you're going to do it right, you can get yourself into a situation. Are we sure the name is Baylor? Like the college or university? All right.
Yeah.
I looked up the name meaning on one of those baby name websites, and it means the one who delivers the goods. And Baylor, that voicemail delivered the goods.
That's awesome.
Right? How nice was that? Are we super chill? I feel like we're super chill.
I certainly strive to be super chill when it comes to this podcast.
You definitely, I don't know that I've ever seen you fired up.
It's pretty rare. It's pretty rare.
I get fired up way more often than I should, but I try to be super chill when we're recording.
Yeah, that's good. Strive for chillness.
In all things. The dude abides, right?
The
I need to rewatch The Big Lebowski.
Yeah. That's just like your opinion, man.
Man. Yeah, I'm definitely more of the shut up, Donnie, you're out of your element type. There is a Donnie I would like to tell that he's out of his element, but
hey, I'll have to tie this
don't have the access. Yeah, this is a more, it's almost like someone figured out how to take all the point cloud references of our normal conversation and lay a cohesive surface over them.
Wow.
Make it all connect.
That was strong.
Baylor, thanks for calling in, man. That was perfect. It was the perfect length of a voicemail. The only other thing we like to ask when people call in the voicemail line is, in addition to your name, where you're calling from. I like to just get a sense. You had a somewhat of an accent, but people move around this great wide world of ours. So let us know where in the world you're calling us from when you do call in. But other than that, perfect voicemail. Short, to the point, and congratulatory or complimentary.
Complimentary. Yeah. Thanks, Baylor.
312 PaleoPOWs at 312-725-3672. All right, that's the end of the episode. Unless, Joe, do you by chance have something to plug?
I do. How about that? So I wanted to sneak this in. As some of our listeners may know, I volunteer a lot with SAE International, specifically with the Baja SAE series. But
SAE stands for?
Well, it used to stand for Society of Automotive Engineers, but it turns out they don't really go by that anymore. I got my hand slapped a little bit for saying that.
Oh, really?
It's SAE International.
It's one of those KFCs where they're just like...
Yeah, it's one of those hashtag brandings things that we're just going to go with it. So it's SAE International, and they are hosting a virtual career fair on January 25th from 1 p.m. to 4 p.m. Eastern Time. It is not just for students. It is for students and experienced professionals. There will be a bunch of companies there. It's like I said, it's a virtual career fair, so you just log in online. But so far, they've got a bunch of companies signed up: Blue Origin, SpaceX, Volvo, Roush, ZF, Denso, Altair, Magna, Honda, Cummins, Mahindra. So there's a lot of companies already signed up. I think they're trying to get more. And so if you're an engineering type or a sciencey type, which, a lot of you are, student or full-time, just looking for a career change, it might be worth checking out. You don't need to be an SAE member to participate. So we'll have the link to the website in the show notes. Like I said, it's January 25th. So it's coming up. January 25th, 2018, I should say. It's coming up. So go ahead and get registered if you're interested.
And in addition to the show notes, Joe, if you remind me, we will tweet and post links on our Facebook page and all that good stuff. So
I will remind you.
Please do. Well, thanks, man. I'm glad that's out there. My plug is I was on the most recent episode of the iFanboy Pick of the Week podcast. So for those of you who hadn't heard, Ron Richards, who doesn't get enough credit for this podcast you're listening to now being what it is, but he was essentially my guy that I was like, Ron, I don't know how to do this. And he was like, get this app, plug it into Skype, download Audacity, and make your podcast. And so a lot of the podcast being possible in the first place was because Ron was willing to mentor me and give me a lot of his time. And he's a founding member of iFanboy and was the guy who told the other two iFanboy guys that he wanted to do a podcast. And he now is working for Marvel and can no longer participate in a weekly comics criticism and review podcast for obvious ethical reasons. And so... No, it's good. I mean, it's good that he got a job.
Yeah, it's good for him.
But that means that the iFanboy Pick of the Week podcast is down to the previous two Jamokes model of podcasting. And to lighten their load a little bit, they brought me on as sort of an occasional contributor. So I've previously plugged my Animation Brain Trust, where we review the animated films typically from Warner Brothers DC Animation Studios. But now... as often as they'll have me, I will be on their weekly show to talk about comics. So I was on the most recent episode. That was Pick of the Week number 615, Joe. Yeah. Right. Well, they've been good about maintaining a weekly schedule.
What?
Hint, hint.
Hey.
As if I like that the hint is like it's your fault. We haven't maintained a weekly schedule.
We're here to support, buddy.
So yeah, so I had a lot of fun on that, as I always do, and the idea to give out patron theses was stolen from them because they give out superpowers to their patrons. So if you want to hear what kind of kooky superpowers I come up with when given the opportunity, you can go check that out there. And that's about it. The year has begun, Joe. Woohoo! Is it a woohoo?
I don't know.
All right,
it's a woohoo. 2017's over. Let's go with that.
Yeah, I'm not feeling great about it.
On 2018.
Is 2018 going to be good?
Yes, optimism.
All right. Did you make a resolution? What you gonna do?
I'm gonna podcast more.
Yeah, with us, or you got another thing in mind?
Nope, with you. I figure if I make it my resolution, you'll have to do it.
Yeah, I like it.
That's how resolutions work, right?
And that way you will competitively exclude Jacob from ever returning.
Absolutely.
Even though he told me over the holiday that he was like, yeah, I got more time now. I might be able to get back into podcasting. I was like, yeah, good luck telling Joe.
Sorry, the engineer spot is taken.
We only need one.
Exactly.
As you know, you only ever need one engineer.
That's right. Iron Man and Batman Begins have both told us that.
Even though they both had butlers and or AIs to build things for them.
Yeah, well, who built the AI? They did, obviously.
It's true. ScienceOrder.com for the show notes for this episode. Twitter, Facebook, phone calls, all that good stuff. Joe is on Twitter at @BatWinnis because we pressured him into changing his Twitter handle to something that wasn't stupid. My fact. Twitter handle is @Haupt. And thanks again to Chris and Tom for chatting with me previously. Thanks to you, Joe, for chatting with me right now.
Anytime.
All right. Thank you all for listening, and we will see you next time with a whole lot more science.
Sort of.
I got to start asking guests to say sort of.
Yeah, so you can drop them in.
So I can, I got to steal that from West Wing Weekly. Yeah, I just got to steal from all the podcasts I like.
Stealing from the West Wing Weekly, I can get behind.
Okay.
What's next?
Visit sciencesortof.com for show notes, links to all the stories we talked about, and ways to interact with the hosts, guests, and other listeners. Science Sort of is brought to you by the Brachiolobe Media Network of podcasts, with audio engineering by Tim Dobbs of the Encyclopedia Brunch podcast. That's all for this week. See you next time on Science Sort of.
Thought the other day, you might be the wrong person to ask this, but maybe just out of luck, I'll chance it. Is the moon solid all the way through? Do we know that?
Oh my gosh! Well,
thinking about like seismic data on the moon, because we've talked about moonquakes, right? That's a thing. I just never thought about it in terms of.
I don't know, Tom. You're way brighter. You're a physicist, so you're like way brighter than me.
Man, now you're gonna put me on the spot. I want to.
No, it's okay. If neither of you know, I'll just cut that entirely. It was just a random thought that I had that I was like, I don't know that I've ever figured out.
I want to say yes, but I can't back that up with any evidence right now.
All right, so we'll put that out to our listeners. If any listeners out there know whether or not the moon is solid, please get in touch.
There's a person on my corridor who can actually answer that, Lizzie Day, I'm sure. So if she eventually listens to this, I'll go knock on her door and ask her.
This is something, okay, so I just went to like a podcasting conference, and something they said to do, and I've heard other people say to do this, and I'm terrible about doing this, is you should always ask the people you're interviewing who would be another really cool person to talk to that you know. So I think, Chris, you just reminded me.
Yep.
Have given me a cool person to get in touch with for another interview later on.
Yeah, Lizzie Day's spot on. Yep, she's a solid Earth geophysicist, I would guess she'd describe herself as, but she's like way smarter than me. So yeah, real scientist.
Awesome.